Greetings! My name is Dr. Fuller. I would like to introduce you to the mathematical world around you. Dividing with fractions often causes confusion. When we first learn about division, our brains are wired to deal with whole values, and we are taught to think about sharing fairly. For example, suppose I have 10 chicken wings. I want to share them between two groups, eat now and eat later. This can be represented by the division statement 10 divided by 2. The idea of fair sharing is that I distribute the chicken wings until either there are none left or not enough for every group to receive one. Sharing the 10 chicken wings means that each group receives 5 wings. This makes sense to us as we understand sharing fairly at a very early age. The same division problem of 10 divided by 2 can be thought of as I want to take the 10 chicken wings and make groups of size 2. This answers the question, how many groups of 2 chicken wings can be made from 10 wings? We can see that 5 whole groups of 2 chicken wings can be made from the 10 wings. Let's look at this way of thinking of division with fractions using a situation and images. Suppose Max is painting and needs 1/2 of an ounce of brown acrylic paint to create one picture. Max bought a tube with 2 1/4 ounces. How many paintings can Max make out of one tube? The division statement 2 1/4 divided by 1/2 represents this situation. This division statement is the same as asking how many pieces of size half are in 2 1/4. I will start with a model so we visualize the answer and the division process. Using pieces of size half, we can measure out whole amounts to see the division process. We can measure out enough brown acrylic paint for 4 paintings. The remaining amount is half of what we need to make one painting. Thus, our answer is 4 1/2. Notice how the visual for the measurement interpretation of division relates to the idea that division is repeated subtraction. Next, let's talk about the standard algorithm of dividing fractions. Some find this confusing because we seem to magically convert the original problem from division to multiplication. However, the magic is just mathematics. First, let's explore the mathematics behind the standard algorithm so you can see why we convert. To begin with, I make the fractions manageable by converting from mixed number form to fraction form. Fraction form allows us to only work with pieces instead of whole amounts and pieces. This statement means that we have 9 parts of size 1/4. We are now measuring out 1 piece of size halves for each painting. But the oblus is just a representation of a fraction, making the statement the same as. This makes quite an unpleasant fraction. Our next steps are designed to remove the fraction 1/2 from the denominator of the overall fraction. The multiplicative identity property states that we can multiply any number by 1 without changing its value. Next, any number divided by itself is 1. I will rewrite the 1 as a fraction using the reciprocal of the denominator. I call this a convenient 1 because I selected a fraction useful to me. In this case, it will help remove the fraction 1/2 in the denominator. When we multiply fractions, we multiply straight across. I will rewrite this as one fraction to show this. If we look at the denominator, we have the fraction 1/2 multiplied by its reciprocal 2 over 1. Any number multiplied by its reciprocal is 1. The overall fraction has a 1 in its denominator. Dividing by 1 does not change the result. Simplifying this fraction gives us 9/4 multiplied by 2 over 1. Notice the similarities and differences to the original statement. The dividend, 9/4, stayed the same. Division has been replaced with multiplication. And the divisor, 1/2, is replaced by its reciprocal, 2 over 1. This is the magic that happens when we convert from a division problem to multiplication. We are just skipping all of these steps by stating these two statements are equal. My next step may be different from what you have seen in the past. I am a bit lazy when it comes to math, which is not always a bad trait. You see, I do not like to multiply large numbers if I do not need to, so I want to simplify the mathematics before I multiply my fractions. To do this, I start with factoring the numerators and denominators. Then I will divide out each factor that appears in both the numerator and denominator. As 2 divided by 2 is 1, the 2 is removed. I will rewrite the simplified statement as one fraction. After multiplying the remaining factors, the fraction resulting is 9/2. Finally, I convert to a mixed number, and the answer is the same as before. Let me go through another example following just the standard algorithm. Rania surveys 63 square miles of ocean off the coast of Georgia. She notes that every 2 1/4 square miles had one school of black sea bass with more than 250 fish. How many large schools of fish did she find? We can think about this problem as how many pieces of size 2 1/4 are in 63. This problem can be written as 63 divided by 2 1/4. Using the standard algorithm, first rewrite each number in fraction form. Next, change the statement from division to multiplication by the reciprocal. The next step is to multiply. However, I factor the numerators and denominators, then divide out common factors in the numerator and denominator to simplify the multiplication first. Next, I rewrite the remaining factors as one fraction. Then, I multiply the remaining factors. Finally, convert to a mixed number if necessary. Rania found 28 schools of fish. The key thing to remember about the standard algorithm for dividing fractions is that we rewrite the division statement to one with multiplication by the reciprocal. In my mathematical world, I have one little problem. Michaela drives a truck and works to prepare for the upcoming hurricane season. On Monday, she must check a 7.5 mile section of power line along a road. Every 1 1/6 mile, she must check a transformer and may need to replace the moisture barrier. How many moisture barriers should she have on her truck? On Tuesday, Michaela marks the ground with flags where she detects underground utilities. She uses flags at a rate of 2 1/4 feet. The total number of feet covered was 234. How many flags did Michaela use? On Wednesday, Michaela is collecting soil samples to determine if chemicals have leached into the ground. She digs 22 small holes to take soil samples along a 71 and a quarter foot stretch of ground. If the holes are evenly spaced, how far are they apart? Thursday, Michaela wants to get ahead of a wildlife problem. She must check each utility pole for bird and squirrel nests that are evenly spaced along a 38.5 mile long road. She checks 33 utility poles. How far apart are the utility poles? Friday, she needs to trim overhanging branches from some trees planted by the city along a 2.5 mile stretch of road. If the trees are planted every 2/5 of a mile, how many trees were planted along this road? Michaela needs my help to submit a report to create her yearly budget. She breaks down the utility line work to see how much work is performed every half mile. This information affects the amount of work as well as her pay. Determine the number of moisture barriers needed every half mile, the number of poles checked for wildlife every half mile, and trees needing pruning per half mile. Take a look, and you will see a mathematical world around you, filled with operations with fractions. In many ways, fractions are easier to work with than decimals. Additionally, when we use measurements, we often compute with fractions. Always remember to change division to multiplying by the reciprocal when dividing fractions, and you will find success.